All right, so let's talk about hypothesis testing for comparing groups. And again, kind of like what we said with the confidence intervals, the mechanics are the same, the idea is the same, but we are looking at the difference between two groups most of the time in this chapter, if not all the time, maybe all the time. So with the z-test, with hypothesis testing, looking at two groups. Our null hypothesis is always going to be the difference from the first proportion minus the second proportion. We're going to assume that it equals 0 as our null hypothesis. And then the alternative hypothesis will be P1 minus P2 is greater than 0 or less than 0 or not equal to 0. So whichever the case may be. Standard error or standard deviation, like we talked about in the last video, is same general formula. And actually, I may have this backwards with it's not that it matters, but standard deviation and P1 Q1 over N1, P2 Q2 over N2. And then we can find the z-score, and it's the z-score that we talked about back in chapter 5, I guess it was, is the data point minus the mean over the standard deviation. And this is the same basic format. The p hat 1 minus p hat 2, that would be our data point. And then the population mean we are assuming is going to be 0. And then we're dividing by the standard deviation. So it's the same format. It might look slightly more complicated, but it's really not. So let's look at an example with hypothesis testing. So the Sleep in America poll found that 205 of 293, or 70% of Gen Y, used the internet before sleep. And then 50% of Gen X used the internet before sleep. Is the difference of 20%, so 70% minus 50%, is that real, or is it just due to natural fluctuations? So our null hypothesis is always going to be P1 minus P2 is 0. The alternative now is this difference. Difference implies we're going to go with a not equal alternative hypothesis. So now the steps are the same. We check conditions. We'll skip that part. So now, if you remember from when we did these in chapter 16 or 18, either one, the step 1 would be the hypotheses. Then step 2, check the conditions. Step 3, find, if we're talking about categorical variables, find p hat, in standard deviation. So find p, this is just our null hypothesis. Find p hat, so this would be p1 hat minus p2 hat, in this case 0.70 minus 0.20, or 0.50, which gives us 0.20. And here we have two n's, so we have n1 is 293, n2 is 469. Then we can find the standard error of p1 hat minus p2 hat. And so that's going to be the square root of 0.70. And then the q would be 0.30, and the n is 293. And we always add these. And p hat 2 or p2 hat 0.5, so then the q would be 0.5, and then the n for this one is 469. And carefully put all that in the calculator. Make sure that you are taking the square root of the whole thing. So maybe do the part under the square root first, get an answer, and then square root that answer, just so you don't, you want to make sure the square root's over the whole thing. So then we get 0.035352. And so now we can find our z-score. So the z would be the difference in our sample proportions minus 0 if you like, although obviously that's not necessary to put in there. And then over our standard deviation. And we get that is 5.657. Now that is an enormous z-score, relatively speaking. So z, as you know, usually less than 3, almost always less than 3. If you get 3 point something, that's getting to be a big z-score. 5 is astronomical, and we can pretty much assume the p-value is going to be 0. P-value is essentially 0, and I think I want to say we have like 0.000, maybe like 7 zeros, 8 zeros before we get to actual digits. So we're going to say the p-value is essentially 0 here, based on this being 5.5, more than 5.5 standard deviations from the mean. So we'll skip the normal CDF here, and p-value is small. We can reject the null hypothesis that the difference is 0, and there is evidence that P1 minus P2 is not 0. Okay, so next one will not quite be such a big difference, so we'll calculate the probability. We'll actually calculate the p-value here on this next one. So for the next one, we have 19% of girls and 28% of boys have easy to find online profiles. Is there a real difference? So again, and we'll say and actually it doesn't matter. We'll say P1 is the girls, P2 is the boys. So P1 minus P2 equals 0 versus the alternative. Again, difference. So this is a two-sided, and since it's two-sided, it doesn't matter which you put as P1 or P2. So we can skip the conditions. P1 minus P2 is 0. P1 hat minus P2 hat would be 0.9 minus 0.28. That gives negative 0.09. Standard error of the difference is the square root of 0.19 times 0.81 over 325 plus the 0.28 times minus 0.28 over 268. And we get about 0.035011. And so then we find the z-score. And so that is negative 0.09 minus 0 over 0.035011. And that gives us negative 2.5706. And so this time we'll calculate the p-value. This is a two-sided, so let's draw the curve. 0 goes in the middle. We'll put our z-score over here. And since it's two-sided, we'll put the positive side over here. We'll shade away from the center. And then our p-value will be 2 times CDF. You can find either one. We'll just find the left side. So negative 100 or negative 10 would be fine as well. For the lower bound, upper bound is the z-score, and then mean is 0, standard deviation is 1. Since we're putting this on a standard normal model, and then we get 0.010 for our p-value. So again, this one is small, so we're going to reject the null hypothesis, and there is evidence of a difference. And again, we saw these when we did hypothesis testing for one proportion. If the p-value is large or not small, let's say not small, so more than 5% or whatever your alpha level is, then you'd fail to reject the null hypothesis. You'd say there is not evidence of a difference. So the same rules apply as far as the interpretation. The mechanics of getting there is slightly different, but not as far. The steps are basically the same, but the mechanics are different for getting there. So in the next video, we'll look at the difference between two means. And again, it'll be very similar to what we're doing, but we'll have to calculate slightly differently. But we'll get you on the next one.